Alright, what's up, bro? Good afternoon. For today, we'll be looking at NTH 205 limits. You're given, let's say in this format, lim x tends to a, y tends to b of f x comma y equals to l. So you're looking for the limit of this f x comma y as x tends to a, y tends to b. The limit of this f x comma y as x tends to a, y tends to b is l. It gets so L is the limit of f of x comma y. Now they said evaluate lim 3x squared plus xy as x tends to 1, y tends to 2. Solution: lim x tends to 1, y tends to 2 of 3x squared plus xy is equal to, you just like substitution, you just put in your value of x, put in your value of y. But it's not like it doesn't have a specific value of 5. It's what I'm trying to say. So it's kind of like the way I understand limit is like, let's say the starting point is let's say 0 comma 0. The starting point is 0 comma 0 for this stuff. So as x now is turning from 0 to 1, y is turning from 0 to 2, it's going to come across different values. So there could be like 0 0.1 for x, 0 0.1, 0 0.2, 0 0.3 for y, 0 0.2, 0 0.4, 0 0.6, 1.2, like that. So till it gets to 1 and 2. So the final answer is 5. But along the movement, there are different values. So it's not like the definite answer is 5. So now you're giving this one. It said evaluate lim x tends to 1, y tends to 1 of x squared minus y squared all over x minus y. Solution: lim x tends to 1, y tends to 1 of x squared minus y squared all over x minus y is equals to, if you just substitute, you have 1 square minus 1 square, which is 1, all over 1 minus 1 equals to 0, and it's indeterminate in mathematics. So we use difference of two squares. Difference of two squares, assuming you have x squared minus 4, you can express this stuff to be x squared minus 2 square, yeah. And when using difference of 2 square, it's going to be x plus 2 x minus 2. You get, if we try to open the bracket, let's try it. X times x is x squared. This will give you minus 2x. This will give you plus 2x. This will give you minus 4. You have x squared minus 2x plus 2x will cancel each other at minus 4. So that's what we'll do here too. Okay, that's what we'll do here. So we express this stuff in terms of difference of two squares, which will be x minus y, x plus y all over x minus y. This will cancel out this. You're going to be left with x plus y. When you substitute, you're going to get 2. And the final question here is evaluate lim x squared y minus 3xy plus 2 as x tends to minus 1, y tends to 3. Solution: lim x tends to minus 1, y tends to 3 of x squared y minus 3xy plus 2 is equal to, just put your values, substitute. The final answer is 14. It's quite simple. The next one on limits is continuity. Continuity. Now, if lim f of x comma y exists, okay, or if lim x tends to a, y tends to b of f of x comma y exists, the second condition, and f of a comma b exists, then for continuity, the limit of f of x comma y as x tends to a, y tends to b is equal to f of a comma b. That's how you investigate for continuity. Now they said investigate the continuity if f of x comma y is equal to 6x squared y plus 2xy at x equals to 1 and y equals to 2. Now solution: I said let a be equals to 1 and b be equals to 2. X is also equals to 1 and x is equal to 2. So you could say that x is equal to a and y is equal to b. Now solving for the limit, very simple. You just put in the values, you get 16. Then you check f of 1 comma 2, you also get 16. So now it implies that lim f of x comma y as x tends to 1 and y tends to 2 is equal to 16, which is also equal to f of 1 comma 2. Therefore, f of x comma y at x equals to 1 and y equals to 2 is continuous. You get, so just like I was saying before, for the limit part, the definite answer is not really 16. It has a long range of value, maybe from like 14, 13, 13.1, depending on the values of x and y. Like I told you, just like a path. So it's moving till it gets to x equals to 1 and y equals to 2. That's when you get the answer 16. But then for f of 1 comma 2 is a definite value where x equals to 1, y equals to 2. You're going to get 16. But for now, this is continuous.